Okay. Just as a reminder, and new for you, at the end of your notes, what are you supposed to do? Write a summary that answers these questions. And in order to answer questions, you should restate the questions to introduce what you're talking about. So please make sure you do that. Okay, we're going to take a step back in time to 9th grade, where you first started learning about functions. So we're going to list our family of functions. Family of functions. In 9th grade and secondary 1, you learned about linear functions a lot. And then you learned a second function that we've also talked about this year already. Does anyone remember what function it was in secondary 1, 9th grade? Starts with an E. There you go, exponential. So we have this function, y equals a times the base, b, raised to the x minus h plus k. I believe we've written that before this year. Okay. Then in secondary 2, he learned a handful of more functions. The whole first half of the year is dedicated to functions. And you first focus a lot on quadratics. So y equals a times quantity x minus h squared plus k. The square being the highest power tells us it's a quadratic. What other functions did you learn last year? There's at least 4 more. Okay. Oh, yeah. Did you learn something called absolute value? Y equals a times absolute value x minus h plus k. Right? So make sure your absolute value bars are nice and tall and long, so they don't look like ones. Then you learned about, we've done squared, which is quadratic, so then you learned about a cubic. A times x minus h cubed plus k. Two more that you learned last year, do you remember? Squares and cubics. What are their inverses? What's the inverse of a square? Square root. Thank you. Y equals a times the square root x minus h plus k. What's the inverse of a cube? Cube root. Y equals a times the cube root of x minus h plus k. And then this year we've added one more. Starts with an R. Negative h. Yeah. Y equals, it's the rational. Rational means fraction. A over x minus h plus k. So you should notice a pattern. Okay, Chip should say that's a lot of k's. Where are the k's always at? At the end? They're after the function closes, right? This first one is called exponential because if you notice the x is in the exponent. After the exponent ends, then we have plus k. This one is called a quadratic because the highest exponent is squared, x squared. After the quadratic, where the squaring ends, then we have plus k. This one's absolute value. The absolute value bar ends, and then we have plus k afterwards. Cube, then plus k. After the roots end, then we have the plus k outside of the root. And after the fraction ends, we have plus k after the fraction. Who remembers what k does to the graph? Anyone? What does k do to the graph? Which one is it? Horizontal or vertical shift? It's the vertical shift. Okay, so probably choose one of the ones that you have down on the bottom, because we could write this on all of them. I'm just going to write on the bottom 2. K is the vertical shift. K is the vertical shift. Okay, so there's definitely a pattern with K. Are there any other patterns from all of the functions we've listed? A. Where's A always? At the beginning, is it always A plus the function? What's the operation that's always applied? Times. Multiplying. A times. A times. A times. This is technically A times 1 over x minus h. Okay, so we have, leave about a line of space. Okay, we have something else to write right there. But A, remember, is our multiplier. A is the multiplier. We've talked about this, and we've written it down multiple times, so let's see if we can remember. There are 3 things we list that A could do. Remember what A does? The steepness. Okay, so here's one situation. When the absolute value of A is greater than 1, what happens to the graph steepness-wise? Steeper. And that's called a vertical, there you go, vertical stretch. Vertical stretch. Steeper. Then we say by a factor of, I'll put a blank, that'll be whatever the value of A is. If it's 5, be getting steeper by a factor of 5. If it was 10, it gets steeper more rapidly, so factor of 10, multiplying by 10. What if A is between, the absolute value of A is between 0 and 1? It's less steep. Okay? Instead of vertical stretch, this time it's a vertical compression. Okay, now sometimes, guys, they try to throw you off. Sometimes we just think everything between 0 and 1 must be a fraction. But what is, like, 7 divided by 2? What's that equivalent to? 3.5. Is 3.5 between 0 and 1? Haley? She started shaking yes for a sec. No! Okay, I remember there were a couple in your book from your assignment on the first section on exponentials that gave you fractions. And lots of people wrote vertical compressions, but they're not. If the value of the fraction is actually greater than 1, it is a stretch. So just be very careful on the fractions. So this is a vertical compression. It's less steep by a factor of whatever the value of A is. And what's the third thing we write for A that could happen? We'll get to that one in a sec. But with A, there's one more thing A does. Less than 0. What type of numbers are less than 0? Negatives. When our graphs are negative, what happens to them? Decline, okay. Styles? Flip. Flips about what? Yep, it flips about the x-axis. So A has a lot. There's 3 potentials. All 3 can't happen, though, because you can't have a stretch and a compression at the same time. So it's either one thing happens because of A or two. The second would be when A is negative, we'd have to also add that it flips. Okay, so we've talked about A, we've talked about K. What else has a pattern in all those functions we wrote down? M? X minus H every time, right? It's always inside the function. X minus H here is in the exponent for the exponential. Here it's in the quadratic being squared. Here it's in the absolute value. Then we have it inside the cube, inside the roots, and inside the fraction, or the rational. Okay, what does the H do to the graph? Horizontal stretch, shift, horizontal shift. So let's put HS, horizontal shift. What if it says minus 4? It says x minus 4. Does that mean go to the left 4? It says x minus 4. Does that mean go to the left 4? No, what does it mean? Right 4. Because what do we say in our head? Opposite. And for the K, what word do we say? Good. Opposite. Same. And write it here too. Opposite in the function. Same outside the function. Opposite, same. Now with the rational function, because we have a denominator, remember you can't divide by 0. So this rational function, if that's a non-removable, also creates a vertical asymptote. But since the rest don't have the fraction, this is the only one that would create the vertical asymptote right there. Do you have a question, Danny?
No, I think that's horizontal.
Yeah, HS is horizontal shift and VS is vertical. Okay? That rings a bell, right? We've done this before? Alright. Since we're focusing on exponentials, I'm going to give you an exponential, and you need to describe the transformations. You'll either have to list 3 things or 4 things. The 4th would come if A is negative, and you just have to say it flips about the x-axis. Okay? So let's move this down. Describe the transformations. When I drag the pen and it like connects all my letters. Alright, example 1. You're going to have to do this on your homework. We're going to describe the transformations for y equals 5 times 0.25 to the x plus 5. Y equals 5 times 0.25 to the x plus 5. Now if you want, you can put parentheses in. They weren't written in the book, but where would parentheses belong? Around the 0.25, yeah. So you could put parentheses right there if that makes it easier for your eye to see where everything is. Alright, so we're looking for A, H, and K. Starting with A. Would you find A and put the value of A up in the air with your fingers, please? What's the value of A? Value of A. What's the value of A? Yeah, there you go. Okay. Now A could do potentially 1 or 2 of the 3 things we listed there in green. Would you please turn to your neighbor and describe what A, being 5, like you all showed me, does to the graph? You either need to say 1 thing or 2 things. Find a neighbor, turn around, and describe what 5 in the A position does to the graph. Heather, could you turn a dentry so he has a buddy? Okay, raise your hand if your neighbor told you their idea and it sounded like they knew what they were talking about. Okay, Eric, what did your neighbor say? What do you think? Do you agree? He said vertical stretch. Yay or nay?
Yay.
Vertical stretch? Why would you say nay?
I would say that, well, it is like the first, like, it determines the vertical factor, but it's more of a multiplier.
Well, it's both, actually. Because what happens is if you have 5, you're going to be going like up 5 and over just 1. Right, rise over run. So that's actually pretty steep. Compared to if we did the reverse, 1 over 5, you go up 1, run 5. That's less steep. Okay, so when we're greater than 1, it's getting steeper, so it is a stretch. Okay, and we do need to say by the factor of 5, like he said. So we have a vertical stretch. Make sure you list it out, please. It's going to get steeper by a factor of 5. Okay. Please find the value of h. Find the value of h and put it up in the air. What's the value of h? What's the value of h? Put it up in the air. Appreciate those putting them up in the air. I think you need to look a little closely. I'm seeing a 5, that's not h. I'm seeing a 1, that's not h. Oh, I finally see a correct answer. He learned from his neighbor. Where is h located? Well, kind of in the middle, but it's always attached to x. It comes added or subtracted after x in the function, which in this case would be in the exponent. I'm glad, I don't know if anyone was slyly put 0.25, that'd be kind of hard to do with only 2 hands, right? It's not 0.25, that's the base. So what's the value of h that's in the exponent with x? 0. So good job. This is the base, b. If you look right here, the base is b. We're doing h. H has to be added or subtracted, but if you look at our function, added or subtracted to the x up in the exponent, there is nothing. So therefore, h is 0. So that's our horizontal shift. Our horizontal shift is none. Horizontal shift is none. Now, if there was actually a number there, say +2, it would take 4 words to describe it. If it said +2, we would say horizontal shift, and it says plus. Which way does that go for horizontal? Yeah, left 2. So it take 4 words to describe it. Horizontal shift left 2. But here we don't have a shift, so we just write none. Okay, find the value of k, please, and hold up in the air. What's the value of k? Good, 5. Great. Please turn to your neighbor and tell them, describe what the 5 in the k position does to the graph. It takes 4 words. 4 words. Okay, Joseph, please pick someone in your general area to tell us the 4 words that the +5 in the k position does. All right, Ariana. What does the plus 5 do? Oh my gosh, I called you Ariana, I'm sorry. Paula. Okay, vertical shift. Do we, oops, I connected those. She said up. It says plus. Do we do the same sign with vertical shift? Yeah, so up 5, great. Now the fourth thing we would write would be if A was negative, we'd say it flips. Do we need to write that the graph flips? No, because A was positive 5. So we're done. You will be doing some of that on your homework. So at minimum you write 3. Even if it's none, you say horizontal shift is none. There would be a fourth one if A was negative and you just say it flips. Okay? Now we're going to get to the calculator part. We're going to create oh, I can't think, sorry, early morning. We're going to create the equation of the function for the given information. So most people have picked up a calculator. If you do not have your graphing calculator, you need to come get one right now. All right, it's ready. Example 2. Please write down anything that sounds important. Oh, it's not. Shoot. Whoa, no, I didn't want to do that. Let's just try this again. Okay. Example 2. I'll read it. Please write down anything that sounds important. Physics problem. Example 2. The best temperature to brew coffee is between 195 degrees Fahrenheit and 205 degrees Fahrenheit. Okay, you don't have to write down the whole problem, but you should write down what's important. The best temperature to brew coffee is between 195 degrees Fahrenheit and 205 degrees Fahrenheit. Coffee is cool enough to drink at 185 degrees Fahrenheit. The table shows temperature readings from a sample cup of coffee. How long does it take for a cup of coffee to be cool enough to drink? Use an exponential model. Okay, so let's see. Macon, what's something important that you wrote down? Yeah, so we know we have to brew it hotter, right, than we would drink it. Same with like hot chocolate and my favorite hot apple cider. I really like hot apple cider. Or tea, right? You boil the water and it's hotter than you would actually drink it. Because if you drink it that hot, what's going to happen? You'll lose all your taste buds on your tongue, right? You'll burn them off. And then for a couple of days, your tongue's kind of like, you can't use it. So it needs to cool. It's cool enough to drink when it reaches what temperature? 185. Cool enough at 185. Okay, what else is important? The question. How long in time does it take to be cool enough? Yes, and we need to write down the table. So please copy down the table. The first column is called time. It tells us it is calculated in minutes. It's counting by 5, 0 to 30. Please write it down if you haven't already. The second column is temperature in degrees Fahrenheit. 203, 177, 153, 137, 121, 111, 104. Do you think when a liquid cools that it cools linearly, like this? It's really hot, and then it cools linearly, so that every minute it cools at the same pace. It has a consistent cooling. You think that's what happens?
No.
What do you think happens? Oh, so you think at the beginning it cools faster and then it gets less and less? So it has a steeper slope and then it gets less and less? Any other ideas? Okay, well, let's write down... No, I think I'm going to do this slightly different. Let's plot the points on our calculator and take a look and see if it looks linear or if it looks like what Styles just described. Okay, so open up your calculators, please. Okay. Clear out anything that's in y equals. Go to y equals and clear it out. Okay. Who remembers how to type in data into our calculator? Remember what buttons we have to use? What button do we use? Not right now. This is important. You'll be after. You'll be behind if you leave right now. Nope. Starts with an S. Ah, we knew he has it. Say it loud. Stat button. Okay, we go to stat. Edit. Now there's a bunch of data. How do we clear it? Up, clear, down. Let's clear everything out. Up, clear, down. Up, clear, down. Okay. So on our notes, let's just jot down what we did so you can do this by yourself too later, because you're going to have to do a problem like this for homework. For our steps, this is what we just did. We went to stat. Would you write these on your notes? Then we selected edit. And then we did up, clear, down. And we've done this before, but this is a good idea. Write down the steps, because you're going to have to be able to do it on your calculator by yourself. Austin, you write down the steps? All right. So we did stat, edit, and then up, clear, down. Okay, time to insert. At the top, please make sure you're in L1. Okay, you have to know where you're inserting your data. Just like on the computer, you have to know where you save your file or you're never going to be able to find it. Okay, at the top, make sure you're in L1. L1 would be our times. Fill those in all the way up to 30. Fill in L1, counting by 5s from 0 to 30. Okay. Arrow over to the right, L2 would be what column? The temperatures. Okay, so fill in 203, 177, 153, 137, 121, 111, 104. Oh! Yeah, okay, I was just looking at a weird angle. Make sure that both columns are even. They should have even quantities. Actually, no. Well, we want it, these are just points, and we haven't had a calculator develop the equation, so it has nothing to graph yet. But we can graph the points. In order to graph the points, though, see above y equals, what does it say in blue? Stat plot. We want it to plot the statistics. Stat plot. So you go second y equals. Okay? Now, plot 1 is probably turned off. We want it on. So you just hit enter to get there. So the things you should have. On should be selected, mine is not selected, so get your blinking cursor on and push enter and it will select it. The type, we don't want a box and whisker plot, we don't want like a bar chart, you know, or a histogram. We want the dots, the points. So make sure you have the scatter plot that's written for the type. In X list, we have L1, Y list is L2. And we need to make sure we have a mark. Don't select the little point, you won't be able to see it. Probably the box is the best one, you can actually see it. Once that is turned on, you can graph it and see the points. Oh, so this point right down here tells me I probably typed one of my data points in wrong. Because notice how it's away from the rest of them? So I'm going to go back in really quick. But, oh, I just put 37 and missed 137. That's my fault. Okay, now some of your windows might be, say, a standard window. Oops. Zoom, standard, number 6. And maybe you can't see the data. Now, yesterday we were playing with the calculator, so maybe you can actually see the data because yesterday fixed the window. But if not, you have to look at your data and see what should we adjust the window to. Look at the time. Are any of the times negative? No. So we could, this is the X, we could set the X from 0 to something a little bigger than 30, maybe 40. So if you need to adjust your window, go to Window, and I'm going to take it from 0 to 40. So X min is 0, X max is 40. But I don't want 40 little lines counting by ones. What can we count by instead? I'd probably go 5s. 10s is a little, oops, doesn't give you quite enough to look at. So the X scaling is what you're counting by. Now the Y's, we have to get all the way up to the temperatures. What's our hottest temperature? 203, so we probably need to go a little past 203. Okay, so X min or Y min, let's put 0 to something past 203, maybe 220. What can we count by? I don't want 220 little lines. You count by 20s. That's your scaling. And then if you hit graph, then you should be able to see the points. Okay, so the question again, was it linear? Was it a constant rate that the coffee was cooling? Or does it have a slight curve to it, making it more exponential? It has a little bit of a curve to it, so exponential would be probably the best fit. So let's write the steps we just did. We went second, y equals, which selects the stat plot. We have to make sure the stat plot is on, that we have the dots, okay, and that we have L1 and L2 selected, and that we have the box. Okay, you need to change your window, 0 to 40, counting by 5s.
40.
What's wrong? It's not graphing? Your range. Just go to Window. You have your Y minimum is bigger than your Y maximum. That's the problem. So make Y minimum like 0. and y maximum 220, and scale like counting by 20s. Okay. Show your window to her and copy the same thing. What? No, you're going to be confused. Okay. Your window is nothing that we talked about. 0 to 40, counting by 5s. 0 to 220, counting by 20s. See, there's the window problem. Okay, so, back to your calculator. Now, what we want to have the calculator calculate for us is a curve, the exponential curve that goes through those points. And since it's real life, it's not going to be pretty numbers. So we have to use the regression formula. And we don't want to do this by hand. So please stay with me. We've done regression before, so it should be a little bit familiar. The only problem is, right now, the way we have it set up, the calculator thinks that we have an asymptote at y equals 0 at the x-axis. It's thinking that the coffee can cool all the way down to 0 degrees. Is that what's going to happen? Eventually, you think the coffee will get to 0 degrees. Is 0 degrees warm, hot, or cold? It's below freezing, right? So what would be the lowest temperature if it was in this room that it would cool off to? Oh, I heard it. Amy. Room temperature. So we have to adjust for room temperature. Okay, so what we're going to do for the next step is adjust for room temperature. Now, sometimes the problem gives you room temperature, sometimes it doesn't. For this one, we're going to use 68 degrees Fahrenheit for room temperature. So what we need to do is adjust all the L2 values and subtract room temperature. So we're going to make a third column in L3, taking all of our L2 temperature values and subtracting room temperature. Okay? So, on your calculator, how did we get back to our list of data? Stat. Go to stat. Then what? Edit. Okay, please be with me. Oh, how do you say your name? Sela. All right. Grab a seat. And do you have a graphing calculator? Okay, we have calculators right there. You'll need one to follow along with what we're doing. Okay, over in L3, the third column, it's kind of like Excel, but not as high powered. So Excel, you could just say a formula and drag the corner and do it for all of them. We can't, unfortunately, put L2, subtract 68, but we can type in 203 and subtract 68, and then when you arrow down, it calculates it for you. Okay, so 177 subtract 68, arrow down, and it calculates it. You have to do that for all of them. Be careful how you type. Make sure you're actually typing in the right values, subtracting 68. Oh, you needed a piece of paper out. We're using those values in that green chart. Sorry? Oh, it's right here. 203. Yeah, we just write in 203 subtract 68 and it'll calculate it for you. Okay, so we use stat edit to put in the data. Now, what do we use to have it run analysis for us? Remember, we've done regression before, and we've done a one-variable statistics test. Class is this way. Okay, we've done stat edit to put in our data. Now, what buttons do we go to run a calculation? You go stat again, stat, and we go to calc. Well, normally it's the first one when we only have one column of data. But we have two columns of data and we want it to be exponential. So we're looking for something that looks like exponential regression. And right now you actually don't see it. We see quadratic regression, cubic regression, quartic. So arrow down until you find exponential regression. What number is it? 10 or the 0. Okay, so hit enter. Yeah? No, not until the lesson's over. You're about the fourth person who's asked me. I've told no to everyone. Okay? I just didn't want the stuff above it. Okay, exponential regression. Okay, now we want two columns of data. So we type in our first column, which was called what? L1. Remember number 1 in blue? It says L1. So we go second, L1. I'll write this on the whiteboard and then I'll put it on our notes. Okay, so again we went to stat, calc, exponential regression, L1. Now we have to do a comma. Look above number 7. There's a button that actually has a comma. Now we're not going to put L2. We're going to put in the adjusted values. What column have the adjusted values? Yeah, second, 3, and then a comma. So we then want L3 with a comma. Now we could graph it now, or we could run it and it would give us the equation, but it won't graph it unless we tell it to. Oh yeah, okay. If you guys have the new version of the calculator, your X list is L1, your Y list is L2, so you can do that by just going Y3, second, number 3. And then what I'm going to talk about right now, who has the new one, the LCD screen?
Oh, what? I want one of those.
Okay, where it says store required equation, that's where we're at right now. Okay, we want the calculator to store the equation so it will graph it for us. We do that by going to the vars button. So make sure you're on the line that says store required equation. We're going to hit this vars button. It's right next to the clear. We've done this before too. Do you remember which one we select? Vars. We did this first term. I know it's been a couple months. Which one do we select? We go to vars. Y vars. Yep. Y vars. Then we want function. We want to write a function for us and put it in Y1. Well, you just push enter and it will do it for you. Okay? So mine now says exponential regression L1, comma L3, comma Y1. If you hit enter, it will run it for you. And you can go to the graph and see it. Or you just go back and delete it. So arrow over, and there's a delete button.
I didn't know that.
Okay, you need to push enter like twice, and it will run it. Okay? So look, it tells us the value of A, it tells us the value of B. And it even tells us what the formula should look like. It's A times B to the X. Okay, so what's the value of A rounded to the hundredths, 2 decimal places? 134.52 times the base times The base. Heather, what would the base be rounded to 2 decimal places? The B. What? No, B. What's B rounded to the hundredths? 2 decimal places. No, they're saying stuff that's not what I'm asking for. Point. No, that's not a 6. That's a 9. 0.9, then 6. This value right here, how is this 0.956? So rounded to the hundredths would be 0.96. To the x. Okay, I'm going to come back to the notes and jot down what we just did. So again, we went to stat, calculate, exponential regression, L1. This time we did L3, comma. The commas are important to separate it. It won't work without those commas. Then we went to vars, y vars. You're going to have to do one of these for your homework, so make sure you have the steps written down. Function, y1. Well, I asked for 2 decimal places. 956 would be 3 decimal places. Okay. And this is the equation we got. Y equals 134.52 times 0.96 to the x. Alright, hit the graph button. See what it looks like. Does it look exponential like a growth or a decay? Okay, it looks like what Style said. Is that a growth or is that a decay? Because it's getting lower, right? Now, does it go through our points? Why does it not go through our points? We had adjusted for room temperature. We subtracted 68, and that brought it down. So our last step is we have to readjust for room temperature, which is to add 68. But all we have to do, that's a vertical shift. We've talked about vertical shifts. Where is the vertical shift on the equation? The K, which is at the, yep, so right here, we're going to put plus 68. And there is our equation. That's the equation. If we put that in the calculator, we'll go through the points now. So hit y equals, and it's really long, but it inserted in for you, which is nice. After the x, you put plus 68, or whatever room temperature was given to you. If you hit graph now, it will go through those points. All right, did we answer the question that was given in the problem? I don't think we did, guys. We found an equation, but what was the question? How long does it take for what? To be cool enough to drink. What's the temperature to be cool enough to drink? 185. So we can use our calculator to do that. However, guys, right now, if you use the trace feature right now, because we put the points, it will only jump point to point, and it misses everything in the middle. So we have to take that off in order to use the trace feature to find the value close enough to 185. So, remember stat plot? That's where we turned it on. So we go second, y equals, which is the stat plot. And we just all you need to do is turn it off. So go in and select off. And then it would graph. And then you can use the trace feature to get as close as you can to 185. What? Now use the trace feature, get as close as you can using the left and right arrows to 185. And we need to know approximately what time in minutes.
2.978. Yep. 7, 2, 3, 4.
Okay. So So I have 185.6 and I have 183.4. Which one's closer? Yeah, my 185.6. So it's approximately 2.9. Mine's is about 2.98. There'll be a little bit of rounding error depending where your calculator is zooming in. Almost 3 minutes. So our answer is, it's approximately, actually we're going to do f of 185. That means the function at 185 is, actually let's do squiggly equal signs, 2.98 minutes. $2.98. There are lots of steps. I hope you wrote it down because you have to calculate one of those on your assignment. I'm only giving you one because did you see how long it was? You want more? Okay, I hope you wrote down the steps. Our assignment is only 5 problems. The first one is like this, so it's a little bit time intensive. For the last 4, all you have to do is describe the transformations. Those go pretty quick. So the assignment is page, not 2, 3. 324, numbers 5 and 12 through 15. Don't forget you also need to write a summary. Just a minute.